Hello guys, welcome to Roland High School Math Room. Today we are going to start with the studies of one of the most important topics when it comes to high school math education. And today's section of the study is on trigonometry. Particularly, we are going to start with the introduction to trigonometry. What perception and what kind of understanding do you have to put in mind when we made mention of trigonometry in mathematics? So here, what is trigonometry? Trigonometry is a branch of mathematics that deals with the relationship between the angles and sides of triangles, especially right angle triangles. The word trigonometry comes from two Greek words, and the first one is trigonon, meaning figure with three angles. And scientifically, when we're talking about three, we can also say tri. So, figure with triangles or figure with three angles. In short, triangles. Then two, metron. The metron here means measure. So when we talk about metron in Greek, we are talking about measure. So we can say that trigonometry, therefore, is the measurement of triangles. But in a broader sense, it is about studying how angles and length interact, not only in triangles, but also in waves, in circles, in rotation, and also in periodic pattern. So when you talk about waves, you have to understand how waves behave. That is sound wave, light wave, and so on. You also have to talk about circles. We also have to talk about rotation. It also talks about periodic patterns. Now, the key idea about the study of trigonometry is such that in its simplest form, trigonometry helps you to answer questions like, look at the first one. If you know an angle and a side of a triangle, can you find the other side? Have you seen the question now? Then two, if you know the height of a building and your distance from it, can you find the angle you are looking at? So these are some of the simple questions that trigonometry answers. Now, look at this particular triangle. So when you look at the first question here, if you know an angle and a side of a triangle, can you find the other side? So these are sides of triangles. So this triangle is a right angle triangle. So in a wider sense, trigonometry is a language of angles. Put in mind, it is a language of angles. So everything about these studies is going to be based on angles, distance, length, angles, distance, length. So in a broader sense, trigonometry is a language of angles and distances that appears in engineering, navigation, astronomy, music, and even art. So here, trigonometry means that you are dealing with angles and length that forms the angles. Okay, so here now class, let's get to know about some simple practical or applicable examples and quick facts that we need to put in mind when it comes to trigonometry. Now let's look at or let's read this particular practical example. Imagine you are standing 50 meters away from a tree. You measure the angle of elevation to the top of the tree as 35 degrees. This practical example here is all about trigonometry. Then the second one is using trigonometry, you can find the height of a tree, which will be 35.0 meters without climbing it. All this is possible with the use of trigonometry. Now let's look at some quick facts about trigonometry. Trigonometry is not limited to triangles. It also describes waves, rotation, vibration. So sometimes students normally think trigonometry is only for triangles. No, it is not limited to triangles, but it also describes waves, rotations, or vibration. Now, the first section of this study is supposed to be the measurement of angles, because we understand that trigonometry is about the studying the measurement of angles, specifically triangles, but it can also be applied in waves, rotation, vibration, and so on. So angles are very much important when it comes to the study of trigonometry. So before we proceed, the first thing that we need to understand is the measurement of angles. Now, definition of an angle. Let's look at this particular diagram here so that we can understand the definition very clearly. Now, let's look at the introduction. An angle is a measure of rotation between two intersecting lines, line segment or rays that share a common end point. So if you look at this diagram, we have two lines, line AB and line AC. They are all intersecting at a point A. So anytime you see an intersection between two lines, an angle is being formed. And when the angle is formed, it means that two lines are meeting at a certain point, which is the point of intersection, also known as the vertex of the angle. So an angle is a measure of rotation between two intersecting lines. So this time you have two intersecting lines with a common end point. This common endpoint is called the vertex of the angle. So here it's called the vertex of the angle. And the two lines or rays are called the arms or side of the angle. So these are the arms or side of the angles. Angles help us describe direction, orientation, and rotation, and they form the foundation of the trigonometry. So if you want to understand trigonometry at its apex, you need to understand the meaning of angle, because that is the foundation of the study of trigonometry. Now let's look at the basic structure of an angle. Number one, the vertex. So this is the vertex, the first point where the angle is formed. This is the first point where the angle is formed. Then the arms, when you look at this diagram, the arms are AB and AC. Then we have interior and exterior. So the angle inside this figure is called interior, and the angle outside will be called exterior. Then initial side. Initial side is the starting point of the angle, so where the rotation started. Then we also have terminal side. The terminal side, that is the position of the angle after rotation. So where you started and where you ended becomes your terminal side. So that is the definition of an angle. Now, how do we name angle? Naming or named, we name angle using three letters with the vertex in the middle. So when you look at this particular diagram here, if I want to name this angle, then the angle will be named B, angle BAC. This is the sign used to write angle. So angle BAC. So we name angle using three letters, and we can also be, angle can also be named by a single letter if only one angle is at the vertex. So here, since one angle is at the vertex, We can also name it as angle A. Then angles are measured in units. Students, let's understand this. Angles are measured in units. What are the units that we use to measure angle? They are known as degrees, radians, and gradians. We are going to understand all these kind of unit measurement in angle under this particular lesson. So measured in units, angles are measured in units, and the units are degrees, radians, and types of angles by size. We have the first one to be acute angle. That is angle greater than 0 but less than 90 degrees. The angle is between 0 and 90 degrees, and this is a perfect example of an acute angle, 40 degrees. Now the next one is right angle. Angle which is exactly equal to 90 degrees. And this is a perfect example of a right angle diagram. So this angle measurement is equal to 90 degrees. Now the next one is obtuse angle, an angle whose measure is between 90 degrees and 180 degrees. It means this kind of angle measure is between 90 and 180, and that is an example of an acute angle diagram. Then we also have straight angle, an angle which is exactly equal to 180 degrees. That is a perfect diagram for a straight line angle. Then we also have reflex angle, that is angle between 180 degrees and 360 degrees. That means its measurement will be a figure or a value or an angle which will be between 180 and 360 degrees. This is a perfect example of a reflex angle. Now, the last one that we are supposed to know is full rotation. Full rotation of an angle is exactly equal to 360 degrees. Normally, we can also call full rotation as angle at a point. Angle at a point. So angle at a point is also equal to 360 degrees. Let's proceed to the next subtopic under this section of our studies, which is on rotation, direction, and coterminal angles. Positive and negative angles is what we are starting with. When we talk about negative angles and when we talk about positive angles, how do we understand them? Angles are measured by the rotation from an initial side to a terminal side around a vector. That is what we've studied so far. So positive angles are formed by counterclockwise direction or anti-clockwise direction or anti-clockwise rotation from the initial side. So when you look at this diagram here, this angle can be called positive angle because it is being measured in an anti-clockwise direction. The negative angles are formed by clockwise rotation from the initial side. So when you move clockwise rotation, we measure the angle as negative. So it means that an angle can be positive and an angle can also be negative. Now, let's look at an example. We have positive 90 degrees. That is in this format, that is positive 90 degrees, which means that quarter turn anti-clockwise. So if someone write positive 90 degrees for you, it means that turn in an anti-clockwise direction form and measure an angle 90 degrees, or quarter turn anti-clockwise direction. And when someone also writes negative 90 degrees, it means we are talking about quarter turn clockwise. So it means that uh, rotate in a clockwise direction and measure an angle of 90 degrees. So positive angles means the rotation is being done in an anti-clockwise direction, and negative angles mean the rotation is being done in a clockwise direction. Now the next thing that we need to know is known as standard position. Now, standard position, that is angles in a standard position. An angle is in standard position if its vertex is at the origin. One. Then two, if its initial side lies along the positive x-axis. So anytime an angle is being termed as a standard position angle, it means number one, the vertex of the angle is at the origin, and number two, it also means that its initial side lies along the positive x-axis, as you can see here, from the origin initial side along the positive x-axis. The next one is on coterminal angles. Coterminal angles are two or more angles in standard position that share the same terminal side. We now understand what standard position is. They differ by a multiple of full rotation. Full rotation is 360 degrees or 2 pi radian, as shown in the formula below. So angle coterminal is equal to this one. The angle is measured in degree. Is equal to the angle, that is the theta, plus or minus 360 degrees times n, where n here represents a positive integer. So here the angle coterminal is equal to theta plus 360 degrees times n in an anti-clockwise direction, or theta minus 360 degrees times n in a clockwise direction. The same process or the same format is used when the angle is measured in radian. So the angle in coterminal form, that is the angle coterminal, the radian, in radian format will be the radian plus 2 pi, where 2 pi represents full rotation, times the n, or the radian minus 2 pi times the n, where this n is a positive integer. So let's look at a perfect example here. Coterminal angle to 45 degrees. We are going to start to find the coterminal angle when n equal to 1. So if I want to find the coterminal angle for this 45 degrees when n is equal to 1, it will be 45 plus 360, that is in an anti-clockwise direction. That will give us 405 degrees, or 45 minus 360, that is in a clockwise direction. That will give us minus 315 degrees, which means that 405 degrees or minus 315 degrees are in standard position with 45 degrees. That is, they also share the same terminal side. That is one thing that we also have to put in mind. So now let's look at find the coterminal angle when the angle is in radian. If I have 1 over 3 pi and I want to find the coterminal angle, then pi on 3, its coterminal angle will be pi on 3 plus 2 pi. That gives us 7 over 3 pi, or pi on 3 will be the coterminal angle in a clockwise direction will be pi on 3 minus 2 pi, which will give us minus 5 on 3 pi. So here, this is a coterminal example in a diagram form. So this is 45 degrees. They share the same terminal. So these angles are called coterminal angles. Now let's put some concept in our mind. So here we have key takeaway. Angles are the language of rotation and direction, forming the foundation for all trigonometry measurement. So the foundation of rotation, the foundation of direction, the foundation of trigonometry it's all about angles. Positive and negative angles describe rotational direction, whilst coterminal angles identify different measure representing the same rotation. Put this thing in mind. Coterminal angles identify different measure representing the same rotation. So if I have 45 degrees here, the coterminal angle is 405 degrees, which is the same rotation as 45. Another coterminal angle is minus 315 degrees, which is the same rotation as what? 45. Now we are on the next section of our studies, and it is on unit of angle measurement. Now let's proceed to the introduction. Angles can be measured in different units depending on the content. The three most common units are degree, radians, and gradians. Each unit offers a different way to describe rotation, and understanding them is essential for mastering trigonometry. So each of the units that you see here is based on the understanding of rotation. Now, the first one is degree, symbolized in this format, that is a zero on top of a figure. And we've been using degree a lot as high school students, but what is the meaning of a degree? A degree is one part of a full rotation divided into 360 equal parts. So when you talk about degree, it means that you are dividing the full rotation into 360 equal parts and you are taking a portion of it. Now, this division dates back to ancient Babylonian astronomy, which used a base 60 number system. So 1 and this symbol on top, that is the degree symbol on top, read as 1 degree means that one side of an angle is rotated 1 out of 360 of a complete revolution about the vector from the other side of the angle, as it has been shown below. So look at this diagram here. The side of the angle is rotated 1 out of 360 degrees of a completed revolution from the other side of the angle. Now, subdivisions, what we need to know is 1 degree is equal to 60 minutes. 1 degree is equal to 60 minutes. And 1 minute is also equal to 60 seconds. So example, a right angle is 90 degrees, a straight angle is 180 degrees. Why are we saying that 1 degree is equal to 60 minutes? Because in the ancient time, the Babylonians time, they used base 60 number system. Now, let's proceed to the next unit of angle measurement, which is radians, in short RAD. A radian is the angle formed when the arc length equals the radius of the circle. A radian is the angle formed when the arc length is equal to the radius of the circle. So a radian is the angle formed when the arc length equals the radius of the circle. So one full rotation or one full revolution is 2 pi radian. So here when it comes to degree, one full revolution is divided into 360 equal parts. But when it comes to the radian, one full revolution is 2 pi radians. Widely used in higher mathematics, physics, and engineering because it simplifies formulas. So the use of radian simplifies formulas more than the use of degrees. Now let's look at some key terms here or key relationships here. I have a circle, and this is one full radius. This is the radius of the circle. I will remove this circle with a thread, and put it on the circumference of the circle as shown below. So from this direction or this side to this side, it means that we are talking about 1 radian. So this is 1 radian. That is when the arc length here become the same as the radius. So you are measuring the circle against its own radius. So you are using the radius of the circle to measure the angle. So here we have the radius here being put on this circumference of the circle, and it becomes one full arc. So, and this arc here have a total length equal to the radius, so we call it 1 radius. And this one, you continue another radius, making it 3. So we have 1, 2, 3 radius. So the portion left, the small portion left, will be a portion of 0.14 of the full radius. So when you look at this one, we are talking about half of a circle. Half of a circle. So here, 180 degrees. When you complete the half of a circle in terms of degrees, it becomes 180. So 180 degrees will be equal to 1 radian here, plus another 1 radian here, plus another 1 radian, making it 3, plus a portion of 0.14, and that will give us 180 degrees being equal to 3.142 radius or radian. So in that sense, remember 3.142 is also approximate to pi. So as such, 180 degrees is equal to pi radian. So if 180 degrees can be approximate to pi radian, then 360 degrees is also approximate to 2 pi radian. So that is the reason why a full rotation in radian is 2 pi. Now let's proceed to gradients, the unit measurement known as gradient. So here a gradient divide a full rotation into 400 equal parts. So here degree divide a full rotation into 360 parts, and gradient also divide a full rotation into 400 equal parts. So one right angle, which is 90 degrees, is equal to 100 gradient or 100 gons. So here we use the gradient in surveying and mapping. So key relationship here is 90 degrees means 100 gons. So 1 gon is equal to 0.9 degrees. Now let's proceed to changing from degree to radians. Using the relation that we've learned earlier, pi radian is equal to 180 degrees. So let R represent an angle in radian and theta represent an angle in degree. So if we are looking for an angle in radian, we are going to use proportion to make R the subject. And when we make R the subject, we are going to have theta, which is the angle in degree I want to change to radian, times pi divided by 180 radian. If I'm looking for the angle which has been given to me in radian to degree, then it will be theta equal to 180 over pi times the radian, the R, where R is the radian and theta is the angle in degree. Now, let's work on some simple examples. The first one is we are supposed to convert 225 degrees to radian. So we are going to use one of the relation here. If you guess, it means we are going to use this particular relation. We want to get the radian, and we have been given the degree, which is the theta, and the theta is 225 degrees. So our solution is going to be radian is equal to theta times pi over 180 radian, and radian will be equal to 225 degrees times pi over 180 radian, and my R will be equal to 5 on 4 pi radian. Now, second example is to convert 5 on 3 pi radians to degree. This time, I am going to use this particular relation because I've been given the radian. I want to change it to degree, and degree is the theta. So here, theta equal to 180 divided by pi times r, and that will give us theta equal to 180 over pi times 5 pi over 4. Pi and pi will cancel. Do my calculation well, and theta will be equal to 300 degrees. So that is how we convert degree to radians and radian to degree. That is changing from degree to radian. Now we have a try work section here. We are supposed to express each of the following numbers of radians in degree. So we are going to use smart way to do it fast. So I have 1 over 6 pi, and remember, in terms of degree, pi is approximate to 180, so it will be equal to 1 over 6 times 180, which is equal to 30 degrees. This one too is a smart way that you can convert radian instantly to degree without any much stress. So here we have 2 over 3 pi, which will also be equal to 2 over 3 times 180 equal to 120 degrees. So it means 1 over 6 pi radian is the same as 30 degrees in terms of degree. And 2 over 3 pi is also the same as 120 degrees. You can try your hands on the 11 over 6 pi. Now, another sections are here. Make sure you work on them and try and give us your feedback for us to help you more to be smart when it comes to high school math education. So number 2 here is we want you to express the following angles from degree to radians, and also express the following angle from degree to gradients. So here we are on another main or sub-important topic known as special angles in degrees and radian. We have some special angles that we normally see them in trigonometry at the day-to-day trigonometry questions. Now, certain angles appear so often in trigonometry that they are called special angles. Knowing their measures and trigonometry values without a calculator saves time and improves accuracy in problem solving. These common angles are shown in the figure below. So now let's look at the common angles. We are going to spend some time here to understand these common angles because they are being used in our day-to-day activities when it comes to trigonometry. So here we have these angles in degree and these angles being changed to radian. So the first angle, common angle or special angle, is 0 degrees. Then we come to 30, then we come to 45, 60, 90, 120, 135, 150, 180, 210, 215, 225 rather, then 240, 270, then 300, 315, 330, and 360. Now, in what common way can you put these special angles in your mind? And that is what I normally do. These angles, I measure them to in the sums of 30s and the sums of 45. So for example, starting from 0 degrees, the next common angle that I need to think about is adding 30 to 0 degrees, and that will give me 30 degrees. The next common angle that I can think about is adding 30 to this 30 degrees, and that will give me 60 degrees. The next one is adding 30 to 60, and that will give me 90. Adding 30 to 90, that will give me 120. Adding 30 to 120 will give me 150. Adding 30 to 150 will give me 180. Adding 30 to 180 will give me 210. Adding 30 to 210 will give me 240. Adding 30 to 240 will give me 270, 300, 330, and 360. So if you ask me some of the special simple angles in trigonometry, I made mention of the angles based on the addition of 30s and 45. So let's proceed to the 45. I will start from the 0. If I add 45 to 0 to give me 45. If I add 45 to 45 to give me 90. If I add 45 to 90 to give me 135. If I add 45 to 135, I'll get 180. If I add 45 to 180, I'll get 225. If I add 45 to 225, I'll end up with 270. If I add 45 to 270, I'll have to get 315. And if I add 45 to 315, I'll, I'm going to arrive at 360 degrees. So this simple or these special angles are can be easily be memorized, can be easily be put in our mind because you just have to start from 0 and keep on adding 30s and 45 till you get to 360 degrees. So these common angles are 0, 30, 45, 60, 90, 120, 135, 150, 180, 210, 225, 240, 270, 300, 315, 330, 360 degrees. Okay, so the next section is on angle length and sector area in degrees and radians. So let's see. When an angle is formed at the center of a circle, it cuts out a portion of the circumference called an arc. So an arc is being formed when an angle is cut out from the portion of the circle. So the region between the two radii and the arc is called a sector. So we know a sector already. So arc length is equal to theta over 360 times 2 pi r. So arc length, this is arc length in terms of degree, and this will be arc length in terms of radian. So arc length in terms of the radian will be arc length equal to the radian divided by 2 pi times 2 pi r. So remember, this 2 pi, because here is 360, and this one is the circumference of a circle, and this one too is circumference of a circle. So 2 pi and 2 pi will cancel. So arc length of a circle in terms of radians will be equal to the radius of the circle times 8 radian. So let's see here where r is the radius, theta is the angle in degree, and r is the angle in radian. Let's look at sector area. So when you want to find the area of a sector in degree, it will be theta over 360 times pi r squared. That is how we find the area. So in terms of radian, it's going to be the radian over 360 means 2 pi radian times pi r squared. When you do your simple cancellation, the area of a sector in terms of radian is going to be 1 over 2 r squared r, where r here is the radius of the circle and a capital R here is the radian measurement. So perimeter of a sector is equal to 2r plus arc length. Now let's proceed to work examples. A sector of a circle has radius 5 meters, subtended an angle of 1 over 3 pi radian. Find I the length of an arc, II the sector area. Take pi to be 22 over 7. So it means this question comes with an angle measured in radian unit. So we are going to use the radian format to solve this question. So solution will be arc length. If I want to find the length of an arc of a circle is equal to, or of a sector is equal to r times r. That is small r times big R, where the small r is the radius of the sector or the circle in question, and r is the angle subtended by the sector, that is in radian. So we have r equal to 1 over 3 pi, r equal to 5 meters. So the arc length will be equal to 5 times 1 over 3 pi. That will give us 5 on 3 pi. And remember, pi has been given to us as 22 over 7. And our result is going to be 5.238 meters. In addition, the sector area is equal to 1 over 2 r square r. Remember, it will be 1 over 2, 5 square, 1 over 3 pi, and the answer will give us 13.09 meters square. So this is the end of the first lesson on trigonometry. I hope this class was very much interesting and understanding. Hope to see you in the next section where we are going to talk about trigonometry, Pythagoras theory, and trigonometry ratios, which I think it will blow your mind for you to get trigonometry at your fingertips. See you soon in our next class. Thank you.